Hello everyone, welcome to the free classroom of Introduction to Computer Networks. Today we will have the pipeline reliable data transfer protocol. The first one is the go back N. Well, later we will already have the details of how or why we want to go back to the specific position. Well, for this kind of reliable data transfer protocol, let us check the sender side first. For the sender, of course, we have the setting of a window. Well, so of course we set it to value n, and at most we have the size of n to send consecutive packets. Well, so we have the illustration. We have the same base. Actually, we can start from the current value, same base. And of course, we can start from this. And actually, we have the pointer of next sequence number. Next sequence number says, here we have this color. Unusable, not yet sent. So that says we can use it later. But right now we don't use it, so we have the base to this one. And at most we have a size of n. Alright, so the current color, sent, not yet act. Alright, and for the previous one actually, already act. So we have this color, and we will emphasize the current window. Specifically, we will emphasize the packet sent, not yet act. So of course, if we have this window, we will have more packet to be sent. Alright, so we assume we have a cat bit to indicate sequence number, like the previous setting for the stop and web protocol. Of course, that protocol is not a pipeline protocol. Well, for go back N, we change our previous way to have the individual ACK. Instead, we have the cumulative ACK. Well, if we have the corresponding N for this ACK, that says from the initial sequence number to the current value N. Alright, so you can see all packets up to the current sequence number N, they are properly received. So we have the cumulative ACK. Well, if we have this one, ACK N, of course, we can move window to the next one. So next one is N plus 1. And for the current version of go back N, we have a timer associated with the oldest in-flight packet. So we just have a single timer. So here we have a single timer. Well, of course, we have N once we have a timeout for a specific packet. You see, so we have a timeout N. If we have a timeout, then we need to get back to the specific sequence number. Actually, all the current window we need to resend. So that's why we have the name go back N. And later we can let you know once we have timeout, we need to start from the oldest one to the whole packets, the newest one. We need to resend all of them. And so this is the go back N. For the receiver side, we have ACK for sure, right? And we use cumulative ACK. And as for the cumulative act, so we should have the in order sequence number 2 to the newest, the highest one, or the freshest packet we receive probably at the receiver. So we can have this cumulative act from the receiver. Well, however, how about if we receive it but the packet is out of order packet? If so, for the current go back N, we discard. And we can buffer as well. As for how to do it, it says, depends on the implementation decision. All right. And actually, we need to have something to do. We ask and we keep it, and then we need to wait for the other packets we see, and then we will check in order or not, and so that we will check everything's okay or not. So at this moment, we have a timeout specificity, and then we need to go back. So here, this is the window. In fact, we can have the window for the sender. Actually, we can have the sender for the receiver as well. So you can see this. We have the expected sequence number we want to receive. So this is the receive base. All right, and here not receive. Right, but some we receive. Right, receive and act. So we have actually some not received, but at these some not received, so not act, so out of order. So of course we have the expected receive window serving as the base, and then we see some of packets, so we will have some receive and act, but some no. So we need to wait the packet, this one. If so, then we will have act for this packet. Well, so we have something mentioned previously for go back N, and right now let us have the go back N in action. Here we have the window. Assuming window size equal to 4, so from sequence number 0 to maybe right now we don't have the limitation, so we have the possible arbitrary sequence number. But we focus on window size equal to 4, 0, 1, 2, 3. And we send 0, 1, 2, 3, but we assume 2 lost, packet 2 lost. So once we receive, and currently we can have the cumulative act. However, we mentioned, okay, we act 0. And here act 1, so it says 0, 1, okay. But no act 2 because the packet is lost. However, we receive packet 3. Because of a cumulative act, so we will send act 1 because up to 1 we receive properly. And for this one, okay, we can, of course, we can buffer, but this time we discard it directly. Why? Because later we will resend, so it won't be necessary to keep it. Well, so send back, and then once we have act 0 that says 0, packet 0, okay, so we can move window to the next one because we have window size of 4, so we can have the actual packet to be sent that says packet 4. And this one, advanced window, we can have a packet 5 to be sent. So send packet 4, send packet 5, and receive it currently out of order, so discard. Currently out of order, so discard. So we choose discard the out of order packet directly. However, about act, always act 1 because right now to packet 1 we can receive properly. Well, and the next one, all right, we have act 1, right? Well, so for packet 4, packet 5, this one we have a timer. Because this one, we don't receive it, so we assume we have the timer associated with the oldest one. So the current concept, okay, we set the timer associated with this because receive, and the oldest one, this one. Up to now, this one receive it, so cancel timer, start the timer, cancel timer, start the timer. And right now, maybe we'll assume we have the proper way to start the timer for packet 2, but once it time out, and then we need to resend all the packet not properly received. So packet 2, 3, 4, and 5, so we send them. And once we send them, yes, receive. So, okay, deliver in order. So act 2, because right now 2 finish, 3 finish, 4 finish, 5 finish. So here we have the possible actions for go back N, GBN. Well, as for the timer, can we have the setting properly for this timer if we have a single timer? In fact, the current version, no. But later we will that know we can enable a single timer. But the time not start from this. And the current version, actually, it should be multiple timer. And once finished, then cancel the timer. Once finished, cancel the timer. So we can maintain this timer from the time instant when send packet 2. So even the previous description for a single timer, but the version here, it is the multiple timer. But we will have a timeout for this one and this one serving as the oldest timer. So of course, once expire, and then we will resend all the packet in flight. Well, so this is the action of go back N. And next one, it's a selective repeat. So selective repeat that says we will tackle the packet individually. So here, individually. So receiver individually asks all correctly received packet. And for this one then, because we want to have the beta efficiency, therefore we will buffer packets. All right, we will buffer packets because we want to check if we still can have the in-order packet, then we will accept that packet finally. So we will have the in-order delivery to the upper layer. If we find the in-order packet, then we can deliver those packets. And of course, we will have a timeout, and timeout this time, it won't be necessary to get back to the oldest one to resend all packets in flight, and this time we just timeout associated with that unapp or those unapp packets. So of course we should maintain timer for, here it's a timer for each unapp packet. Therefore this one we have multiple timers. Right? Multiple timers for selective repeat. Of course, if we check the timer for the packet, it's just a single timer for a single packet. Likewise, we have sequence number N, and similarly, we can have these, right? So send, not act, but maybe some act, right? So we try to weigh, okay, any possible chance to receive packets for those unapp packet before some of the received packet. If yes, then we have in order one, then we can advance window, and then we can advance window. So this one similar to go back N, but we want to tackle the packet individually. So we have a sender window, and of course we have the receiver window For this one, you can refer to the concept of GBN. I go through this quickly. Well, this time, we already have this kind of description. Something like we have an algorithm. Rather than the finite state machine. So if we have data from above, then we try to check available to send if we have larger or maybe current window size still have the room to send the packet. If yes, we will make packet and send the packet. And as for timeout, and because we have the individual one, so we will resend that packet, says packet N. And of course, we maintain timer for that packet, so we should restart the timer. And once we see act N, what it means, if we have this act N within the current sender window, then we will mark that packet received because maybe not in order, so we will mark it. If the current sequence number is the smallest ACK packet, and then it's okay, we can advance here. Advance means we can move window to the later one. So we can advance window base to the next. In fact, you can advance one by one, advance, and then okay, the previous one received properly. Once we advance to the next one, same, and then we can deliver and advance again. So continuously move to the next ACK sequence number. So this is the sender side. As for the receiver side, here, same, we will check packet N within our receiver window. So we have the two sides, sender window and the receiver window. Each side need to maintain the window properly. For the receiver side, of course, we check the window we expect. If yes, sure, we will send ACK N because received properly. Even out of order, it doesn't matter. We can buffer the packet. So we still can buffer the packet once we think, okay, we can fill in the hole. Then we can deliver. So we buffer the out of order packet first. And once we have the in order receive packet, then we can deliver to app layer. Right? And how about if we have a packet but not within our expected window? It should be the previous, maybe previous window size. And so something like we have the previous window size and the current window. And current window size, oh, okay, it's N again. So the previous one, once we receive it, what to do? Actually, we will send ACK. Why we should do something like that? Because we still need to tell the sender. Because sender, perhaps we have the leg, sender. And this is receiver. So maybe we have a leg. We need to tell sender mission completed. So you can move to the next one. Of course, we need to send ACK and so that sender will process properly. Or otherwise, for the other, ignore. So we have the algorithm description for the sender side and the receiver side. Well, let us have the selective repeat in action to check how it works. Same, we have window size N, and same, we have a packet to loss. So we send individual ACK rather than the cumulative ACK. So ACK 1, so here it's ACK 3. But for the current packet, not in order, so we need to buffer packet 3. And we have ACK, so at 0, so we advance window, and then we can send 4, and likewise this one we can send 5. Send at 4 and 5, but we need to buffer packet 4 and buffer packet 5. And this one maintain the timer for packet 2, so same, we need to have the timeout and then resend. Alright, we need to resend. So resend, then we send packet 2. But we cannot advance window, we just send packet 2. And we assume receive packet 2 properly, so we can deliver packet 2. And also we check we have a packet 3, so deliver packet 3, 4, 5 to 5, and then we have an ACK for the current one. It's packet 2, so send ACK, and then no need to resend packet 2 because we receive properly. Therefore, selective repeat using this way, we will have a better efficiency. Right? So that's why we want to have the individual ACK for the selective repeat. Well, right now we want to have one possible problem. Here we call the dilemma. Well, a dilemma, what it means? Assume if we follow the current setting, assume sequence number 0, 1, 2, 3, just 4. Alright, sequence number is 4. So we have the sending 0, 1, 2. And we have a window size 3. Alright, so under the setting, I just let you know the setting. As for the setting, correct or not. Later we will let you know correct or not. But according to the setting, assume we have the window 3, so 0, 1, 2. So first situation or first scenario. We have the possible sending. So this one seems to be okay. But this one, alright, so we assume this is the sender side. We have a situation like this one. Alright, and the sender side here. But look at this. For the receiver window, same. Right? But right now we have a packet. We have the current packet. We have the current packet, packet 0, and packet 0. So same status at the receiver side, right? However, look at this, the current 0, which 0? It's this 0. And how about the current 0? It's the previous 0. So the 2 0 for the receiver side. Well, we have two situations. From the sender side, but for the current packet, same sequence number. Therefore, the receiver side cannot tell. Alright, the 0, same or not the same, because we just have the sequence number 0. Therefore, it's a dilemma. The receiver cannot tell situation 1 and situation 2, the 2 0, they are not different. because from the receiver side, it just can tell it's a packet with a sequence number 0, also it's the old sequence number, or the new sequence number. We cannot tell. We just have a number there. So it's a dilemma. Well, so the meaning of a dilemma here, this is the meaning of a dilemma. We cannot do further. So that's why we have a dilemma. Well, so I don't know this is a setting where we don't have the correct setting. I don't know we have the size of a sequence number is 4. And we have window size is 3. So what's wrong? Actually, we should have number of sequence number larger than or equal to 2 window size. And check the current one, 4 larger than or equal to 2 multiply 3. No, because of no, so it doesn't work. Well, so how to correct? In fact, you can try to extend 0, 1, 2, 3, 4, and 5 at this. Or maybe you can choose the other possible sequence number. And if so, we meet this requirement. Then we won't have this kind of dilemma. So this kind of dilemma, it will happen in go back N, possibly. So the dilemma for selective repeat and also possibly for go back N. Well, so this is the current discussion for selective repeat and go back N. And up to now, I think we have the simple summary, go back N, selective repeat. And talking about the windows, talking about the buffer size. So, sender, receiver, sender, and receiver. This one, sender, of course, we have N, but receiver discard directly. So window size, the buffer size can be set to 1. However, for selective repeat, sender N and receive N. So here N means at least. All right, so if we want to have the comparison for the current version of go back N and selective repeat by checking the buffer size at the sender side and checking the buffer size at the receiver side. For go back N, we have N at this for the sender and 1 at this for the receiver. And of course, if we just have the proper size, it should be N and 1. And likewise for selective repeat, it's N and N for the current buffer size. Well, so this is a version of selective repeat and the possible problem of dilemma associated with selective repeat and possibly for go back N. So, actually, I already have the answer, this one. We should have a relationship between sequence number size and the window size. I already have this. Number of sequence number larger than or equal to 2 window size. All right, that's it. So this is a solution to this kind of dilemma. Well, that's it. So this is the current part of reliable data transfer, but we emphasize it is the pipeline. And the pipeline reliable data transfer, we already have 2 versions, go back N and selective repeat. All right, so this is the first part we want to discuss in the free classroom. And the next part, I reserve it and create a new free classroom video later. Okay, so thank you to join the first part. Reliable pipeline, reliable data transfer. That says GBN and selective repeat. Alright, later I will start the second part to talk about the Connection-Oriented Transport Protocol, TCP, and of course we will check reliable data transfer for TCP as well. Besides, we will check the segment structure, flow control, and connection management. Well, later I will have it. So let me start this one and we'll restart soon. Maybe an hour later or maybe a few minutes later. So that's it and see you. Bye-bye.